Hello and welcome to the part 4 of lecture 4. We will continue our discussion on loop control structures in Python. So far we have discussed in detail two of the major loop control structures available for Python, the for loop and the while loop. So we have seen that for loop is used in definite scenarios where you know the number of repetitions beforehand. So while loop is different, as we have told repeatedly. Uh, it needs more control. So the responsibility is for the programmer to decide when to first to set the condition and define the stopping criteria as well for the loop repetition. Otherwise, it can yield unwanted results if you do not correctly configure a while loop. However, in both type of looping operations, sometimes it is necessary to take actions within the structure before the condition is actually evaluated. This means to abruptly change things. For example, you do not let the for loop run its full length, its full sequence. You need to jump in at the middle and let's say you need to get out of the loop if a certain condition is fulfilled. So that kind of a scenario can also be handled with special keywords that are available. So the first one is the break keyword and the second is the continue keyword. There's another keyword that is available in Python and that is used. It is the pass keyword. We will also introduce that briefly, but we will see first how the break keyword and continue keyword allow manipulating a looping structure in Python program. So the break keyword, we will first look at the break keyword. So this is used to terminate a loop abruptly. So we do not let the loop continue in its normal course of run, but according to or based on some condition, we break out of the loop. Or in other words, terminate the loop and let the program go progress with the other statements by exiting the loop. So what happens is whenever break statement is hit or the break keyword is hit, loop will exit. Control will be transferred to the first statement following the loop block. So we will soon see an example how to do that. So generally, it is advised to use or protect a break statement inside an if condition or if statement, because if it is not handled properly, you will break a certain loop in an unwanted situation. So you do not need that to happen. You need to you need your program to work exactly according to how you need it to work. So it is important that you use these keywords carefully. So now we look at an example to demonstrate how the break keyword is used alongside a for loop. So let's look at this sample program, which is a simple one. That starts with an assignment of 10 to the variable named end in, and there's a for loop defined. So the iteration variable is called var. The range is defined as 0 n is 10 in this case. So inside the loop, body of the loop, we have a print statement, a hello world print statement, and then there's this condition, if condition checking whether the var or the var variable is equal to 5. So what happens if var is equal to 5? We are first, so inside, so you notice the indentation. So these two code segments or these two lines are inside the if condition. So if this is satisfied, the execution will come into these two lines. So what is in the first line within the if condition is a print statement saying countdown aborted. And then you see the special keyword break. So what did we say? When inside a loop, whenever the execution sees a break statement or the break keyword, it will immediately get out of the loop, which is a for loop in this case. And so that is expected to happen. And then finally, when it goes out of the loop, breaks out of the loop, it will come into whatever the statements, whatever the lines of codes that are after the for loop. So what we have there is another print statement saying end of the program. So we will now see on the Python tutor how this program operates. So here we go with the Python tutor. We are going to try the example that we just introduced. So n equals 10, we all know how the program is arranged. There's a for loop and there's a condition check inside the for loop, and inside the condition we have the break keyword. Whenever this as once this condition is fulfilled, it will break out of the loop. So that is the expected behavior. Let's confirm that by running this program. So I hit next. So n value is 10. Now it is coming to the for loop. I hit next. var is 0 because the range is starting from 0 to 10. So there will be a sequence of 10 numbers starting from 0. When I hit next, it will print hello world. Now it is next, in the next line it is checking whether var is equal to 5, but it is not. Therefore it will not go into the if condition. It will not fulfill the if condition, and hence it goes back to the next iteration of the for loop. And now var is 1, and will once again print hello world, and condition check is not fulfilled again, goes back to the next iteration, and now var is 2. Once again condition check is unsuccessful, goes back to the next iteration of the for loop, and now var is 3, prints hello world again, and goes back to the next iteration of the for loop. Now var is 4, still this is not satisfied, so it will once again go back to the next iteration of the for loop. And now what happens, the var value is now 5, it is the next item in the sequence, and now a special thing will happen. Now this condition, as you can see, will be satisfied because var value is 5 is equal to 5, and now it will go into the if condition, whatever that is inside the if clause. So there's a print statement first, so countdown is aborted. So now it will now in the next step execute the break statement. Okay, now you see it did not go into the next iteration. What happened immediately was, as soon as it saw the break keyword, it came out of the loop. No warnings, no nothing. It comes out of the for loop and goes into the next section of the code, which is this print statement. Now in the next step it will execute the print statement and the program will be terminated. So yeah, that is the end of the program. So that demonstrates the usage of the break keyword and how the break keyword lets us manipulate the control flow of a looping structure. In this case, in this example, it was a for loop. So notice very carefully, and whenever you need to use the break keyword, use it with care, because it can, if you don't use it correctly, it can abruptly terminate your for loop in an unwanted manner. So that needs to be avoided. The next important keyword related to manipulating loop control structures is the continue keyword. So what does that enable us? Uh, if we use continue keyword inside a loop, it causes the program to skip the rest of the loop body in that iteration, which will cause it to continue with the next iteration of the loop. As soon as the program execution sees the continue keyword, it will stop. It will not continue. It will not proceed with that iteration anymore. Instead of that, it will go back to the next iteration. So that's what the continue keyword does in a loop. So this is used to jump to the loop control statement abruptly. So we, in the middle of an iteration, we enable the control to be taken to the next iteration, starting point of the next iteration. So that's also an abrupt change. So once again, once this continue is hit, it will go back to the next iteration and the loop condition will be evaluated. If the loop condition becomes false or not satisfied, it will exit the loop as in the usual manner. Similar to the previous occasion where we used break keyword, continue statement should also be protected inside an if statement, because you see what happens, right? Whenever the program execution sees the continue keyword, it will stop that iteration at that point. It will not continue performing that iteration at that point, and it will go back to the, or it will go to the next new iteration. So it has to be used with care. That's why it should be protected with an if statement that has a valid condition check. So how this continue keyword work in the two different types of loops? So first of all, in a while loop, it will jump to the test statement. It will stop whenever it sees the continue keyword. It will stop continuing with that iteration that it was in, but it will go back to the condition check to start a new iteration. So that's what happens in a while loop. In a for loop, it will also jump to the test and perform the next iteration. So basically allows to start a new iteration. So that's how the continue keyword operates. Here's an example of the usage of continue keyword. Now here we have a for loop. Uh, there's the iteration variable I, and the range is defined as -5, 6. So that means it will provide a sequence of numbers starting from -5 up to +5. So we are going to do a division uh, of numbers here. So the problem is, so we are going to divide number 5 by all the possible values that we get from this sequence of numbers. So starting from -5. So in the first iteration, it is expected to the number 5 will be divided by -5, and the result will be printed. So, but however, there's a problem. Because of the nature of this sequence, it will include 0. So there'll be an occasion at some point in this sequence, because the 0 also included, there will be a problem of division by 0 in the case where I becomes 0. So we need to avoid that. That's why we have a condition check here, whether I is equal to 0. What do we need to do if I is equal to 0? That operation should not continue, because this is a division operation. So if I is equal to 0, for that specific case, we don't want to proceed with this operation. That's why we put the continue keyword in this if statement. If I is equal to 0, we ask the program execution to continue. That means do not proceed with this iteration, go to the next iteration. So in the next iteration, I will not be 0, and then it will not satisfy this condition. It will normally go to this print statement and work accordingly. And eventually, with this, when this range is finished, when this sequence is finished, eventually there will be a print statement at the end as well. So we have so far looked at two important keywords, the break keyword and the continue keyword. And as I mentioned before, there's another keyword called pass, which enables us to use in special cases. So whenever we use pass keyword inside a loop, so this is used in a situation where we need a statement syntactically. We need to have something there, but it is not the actual operator. It does not do anything, but that means you do not want any command or code to execute. So you may be having something to do in the future, later stages of your program development, but right now you do not need anything to happen there. So typically used when we have a loop or a function that is not implemented yet, but you have the loop in place, but inside the loop you do not do anything. So that's when you use the pass keyword. So it will not do anything, it will not go through any iterations, but it will be there. It will work as a placeholder for anything to be added later on inside the loop. So the reason is we cannot have any empty body in Python. So if you did not have anything here, Python interpreter will complain there's no body in the for loop. So you can't have that. So that's why that's when you can use the pass keyword. So can use the pass statement to construct a body that does nothing. So if you try this code, nothing will happen. It will be okay. It's a valid Python code, but it does not do anything. So pass keyword is used in such situations. So now we look at another exercise, a little bit more complicated one. So we are expected to write a program to print all the prime numbers between 1 and 100. So assuming that we know the definition of a prime number. So what is a prime number? A number that is only divisible by itself and number 1. So we can understand which we actually know what those prime numbers are. So programmatically we should write a Python code to identify all the prime numbers between 1 and 100. So we can look at this example. So you can first try this exercise by yourself, and we'll definitely discuss this in the next stage. Now we look at how we implement the exercise. So this program uses a nested loop, a nested while loop, to find the prime numbers between 1 and 100, or 2 to 100. So including 2. So we don't even have to consider 1 since so we are expected to find the prime numbers between 1 and 100 anyway. So we can start from number 2. There's a first while loop which is checking whether I is less than 100. So it will not go beyond 100 uh, because we are targeted to find the prime numbers between 1 and 100. So that is the first loop. First, or the inner while, sorry, the outer while loop is defined here, and then there's another variable defined j, once again initialized to 2, and then we introduce the inner while loop. So there's a check. So this condition checks whether the value you are dividing is less than less than the value you are getting, because there's no point in dividing from numbers that are larger than the number, so it will give anyway. So we need to check whether a certain number is only divisible by itself. So there's also no point in dividing by numbers larger than that specific number. So that is why this condition is introduced. And in the next, inside the inner while loop, we have another condition check, not I modulo j. So this will be true. What will be true? Not I modulo j will be true if I is divisible by j. So if that becomes true, that means this number is divisible by some other number less than that. So that in that case, we do not need to consider that number. That's why the break keyword is there. So whenever this happens, whenever this condition becomes true, a break keyword is there to skip that instance. We don't want that I. So that is to determine whether the given number, the given I value, is divisible by any of the numbers that are less than I, right? So if that condition, as I said before, if this condition is fulfilled, that means if this becomes true, the inner while loop will break. And if that does not happen, it will now increment to the next value. So what happens is it will check now whether j is greater than I divided by j. So this, in this case, this we have determined I as a prime number. So this is the situation, or this is the condition that we reach, or that we decide that I is a prime number. So once that is done, we need to increment the I value, because we need to go to the next iteration. All right, so because we need to find all the prime numbers between 1 and 100. So outer while loop takes care of iterating through all the numbers between 1 and 100. So eventually, or when all this is finished, all this is completed, there's another final print statement outside both the while loops. So that marks the end of the program. So we will try this out in the Python tutor visualization. So here we are on Python tutor examining the example, the prime number identification example that we just introduced. So we kind of have an understanding of what this code is doing to identify the prime numbers between 1 and 100. So let's try to go through the step-by-step manner to identify what the program is doing. So we have the I value initialized to 2, and it goes into the outer while loop. And in the next step, inside the outer while loop, j is initialized to 2, and then it goes into the inner while loop. And you see that this condition is not fulfilled, and therefore it checks whether this condition is satisfied. So here 2 divided by 2, so we know that I value is 2 here, so it should be identified as a prime number. So 2 is prime, so that is okay. So we are expecting that is an expected identification. And now, so the first prime number is identified, and then the I value is incremented. So now I becomes 3, j is still 2. So we go into the next step. So in this step also this condition is not fulfilled, so immediately it goes into this condition, which once again is fulfilled, and 3 is also identified as a prime number. Goes to the next iteration where now I is 4, so this will be different. So now we proceed with j equals 2 inside the fresh iteration in the outer while loop, and now this condition will be now fulfilled because I is 4 and j is 2. That means it's 2 and j is also 2. So this condition, this because it is a less than or equal to comparison, it will be fulfilled. So going now into the inner while loop. So what happens here now? I is 4, j is 2. What will happen to the modulo operator? So I divided by j will be 2. So that means I is divisible by j. So this modulo, not I modulo j, would be true. Because of that, the execution will hit the break keyword. So it will not proceed the next steps. It will go to the condition check of the inner while loop. So once again it is checking whether j is greater than I divided by j. It is not. Because of that, this condition is not fulfilled, and this I, what is this I? It is 4. It is not identified as a prime number. So what happens next? I will be incremented by 1, and now the execution will go back to the next iteration of the outer while loop. So this procedure will go ahead, continue until we go through all the numbers in the all the numbers between 1 and 100. So in this manner, this program allows us to identify all the prime numbers between 1 and 100. So look closely and carefully and try to understand how that operation is done using the modulo operator and division and condition checkings. So it also uses a nested while loop to do this. So once again, as we have mentioned at the beginning, this may not be the only way of doing it. There may be other ways of doing it by slightly changing the change in the program. You should be able to find other ways to do the same thing and get the same output, basically to identify the prime numbers. So I will not go through all the steps because it will be a large number of steps within this program. So I would recommend you to try this out on Python Tutor and understand what happens at each of the step in this program. What have we learned in this lecture? In overall, we discussed two major loop structures, the for loop structure and the while loop structure, and we discussed multiple examples and even went through Python Tutor visualizations for those examples. And during the later stages, we looked at other ways of controlling loops using keywords like break and continue. So we have done a comprehensive study of looping control structures with regard to Python programming. So please go back and revise, look at further examples in your notes and practice those examples, because you have multiple ways of running a Python program. You probably have installed Python on your computers, or even you can use some other tools on like Jupyter Notebook on the web to try out these examples. So it is highly recommended that you try out these examples, not just what is given to you, but any other thing that you think can be done using the new concepts that you have learned. So that brings us to the end of this lecture. The full lecture number 4 is now complete. So I will see you with another lesson. Thank you.